We are going to learn about graphing systems of equations. So we've already learned how to graph equations and inequalities. Now, systems of equations is whenever you have two or more equations that you graph on the same plane, the same coordinate grid. So systems of equations are a set of two or more linear equations in the same variables. I don't like that color. It's really hard to see. Is that better? So a set is when we have two or more. We're going to focus in Algebra 1 with two equations and two variables, x and y. So solutions to a system, graphically, it's going to be the point where the two lines intersect. Sorry, it's hard to see. So you're going to graph both equations on the same graph. And then where they intersect, that's going to be your solution. It's going to be a point. You can also solve a solution or solve a system algebraically by looking for the point that makes both equations true. Okay, here are types of solutions. When you graph them, let's say these are the two lines that you're graphing, that point of intersection is your solution, and it'll be written as an XY ordered pair. If you have parallel lines, they're never going to touch. So that means it will have a no solution. And then if you graph the same line on top of itself, then they intersect at every single one of those points. So it's called infinitely many solutions, or infinity. So let's talk about the steps for graphing systems. So solving systems of equations by graphing. Step 1, graph each equation in the same coordinate plane. I did not spell coordinate right. There we go. So on the same graph. Step 2, estimate the point of intersection. So you're going to look at the graph and kind of estimate where it's at, what x and y value is it at. And then step 3 is going to be to check your solution by plugging it into each equation. So check the point of, the point from step 2 by substitution in both equations. And I'm going to teach you how to graph them also and find that point of intersection. All right, so we have two equations here on example 1. We are going to graph both of those on that coordinate grid and then find out where they belong or where they intersect and then substitute in to make sure it is true. Okay, so let's look at y equals x minus 3. So on y equals x minus 3, we are going to plot the y-intercept for the first one. So down 3. And then we are going to do our slope. If we have x, our slope is 1. So we're going to go up 1 over 1. Grab another point. Up 1 over 1. The more points you do, the more accurate your line will be, especially whenever you graph it on paper. If you need to check it in the calculator, you can. And we need this line. We can make our own line if we want. Or we can use the line that's over to the side. Okay, that looks pretty good. Okay, the next one is y equals negative x minus 1. So we're going to plot the negative 1. Because that is our y-intercept. Then we are going to go down 1 over 1. What happened right there? They intersected, yeah. So let's go down 1 over 1 from there. Do a couple more points. And make your line. I'm going to just make a line this time. And then get your scribble tool and circle where that's at. I'm going to circle it and make that red and thicken it up a little bit. Just so I know, that's my point of intersection. Make sure you extend both lines all the way across the whole graph. Okay, so it is one solution. So let's write what the ordered pair for that is. Positive 1, negative 2. 1, negative 2. Type it over here. Make that bigger. Okay, now we need to double check it. Okay, so remember how we did that in our calculator? By plugging it in. So we plug in the y value and the x value. So let me pull this up, slide this over. It'll only let me do like that. I don't know why. It won't let me pull it in a little bit. Okay, so I'm going to do, on the first one, the y value, we're going to plug in a negative 2. And we were doing the less than all those symbols, but we can also do the equal too. So let's do second test for equals. X would be 1 minus 3. 1 means it's true. Then we need to do the other one. So the y is -2, so we'll do -2 and then do the second math, which is test, equals negative, and then the x is 1, right? 1 minus 1. 1 means it's true. If it came out 0, that would mean it's false. Let me show you the other way of checking. We're going to put these equations into y equals and find our intersection point. So everybody go to y equals. Get your calculator. If you don't have a calculator, get one now. Hey, remember yesterday how we did the inequalities? We had to change this. I need to change it back. So I got to go back over here and change this back to a regular line. Oh, there we go. So if yours is changed, make sure that these are lines instead of that shading that we did yesterday. So let's put it in. X minus 3 for the first equation. Negative x minus 1 for the second equation. Hit graph. Looks the same, right?
Yep.
Okay. I want you to hit trace. Okay, so if you hit trace, you can kind of go along and you can kind of estimate your intersection point. Okay, that would round to 1 and -2, right? But we can get our calculator to actually give us the exact, okay? So do y'all remember how to calculate the intersection point? I think y'all learned last year, but let's go ahead and do it. So it'd be second trace, which is calculate. We're calculating something. What are we calculating? Intersection, so that's number 5. And then we hit enter 3 times.
Yeah.
Enter, enter, enter. 1, -2. Cool, right? And that's exactly what we got. So I just showed you 3 ways of finding your solution by graphing. By hand, checking it with our test, like that, and then also graphing and calculating the intersection point. So let me just repeat the steps real quick. You go to y equals, you put in your y1, y2. You hit graph, check and make sure it looks like yours. And then go second trace, which is calculate. Number 5, which is intersect. And then enter, enter, enter. There we go. All right. So let's go back over here. We need to go to slide 12. Okay, let's do the next one. So y equals 2. What is y equals 2? What kind of line is that? Horizontal. Okay, let's see. Do we have some points over here? Yeah. I'm going to grab this point, drag it over at +2. And it's a horizontal line. I'm just going to insert horizontal line, just draw it myself. If you would rather do this on paper, you can, and then just take a picture and upload it. You don't have to do it on the computer. The next one is y equals 1/3 x plus 4. You should be graphing this. So our y-intercept is at +4. I'm going to grab a point. So +4. I'm going to copy and paste that same point. And then we're going to go down 1/3. Down 1/1, 2, 3. Okay. Down 1/3, 1, 2, 3. And now draw your line. Okay, so our intersection point, let's go ahead and circle it. And I'm going to color it red and then darken it up. There we go. Okay, so we need to create a text box. Let's estimate where that's at. What point is that at? 6, 2?
Yes.
Okay. Okay. So we have our point of intersection. It says calculator check. So you need to check in the calculator. Go ahead and go to y equals and put them in. And we just want to make sure it really is 6, 2. So y'all, I need somebody to tell me how to find the intersection point. What are the steps? Yep. Second, trace. Number 5, enter. 6, 2. And then you could also do the calculator check by plugging in 2 here. Well, the y is 2. 2 equals 2, right? That's good.
Yes.
Okay, 2. I'm going to do the other one. 2 equals, because that's your y, equals -1/3 times, what's the x? 6 plus 4. And that is true. So calculator check, we can put a little check mark there. Woo.
Oh, how'd you make it go straight like that?
I'm just that good. I'm just kidding. I don't know how I made it like that. Okay, let's do the next one. Y equals negative 3x minus 5 and y equals negative 3x. Gonna pause the video so y'all can do this one. Okay, let's look at it. The lines actually have the same slope. They both have a negative 3 slope. So they are parallel, which means they will never touch. So what kind of solution is this? No solution. There we go. We can, let me see. We can insert a symbol for no solution. So go to insert, special character, and then draw it here. And there it is. No solution. So you draw it to be able to come up with it. Do y'all see how I did that? Go to insert, special characters, and then down here in the little space, you can actually draw your symbol and it'll come up with it. Come up with some options. Oh, there's a heart. All right. All right, the next slide, slide 13, we are actually not going to do that one. So we're going to hit delete on slide 13.
We're just going to delete it?
We're going to delete it.
Wait.
So now we're on a new slide 13, which is this one. So check yours compared to mine. Y equals negative 2 over 3x plus 2, and then 2x plus 3y equals 6. All right, so let's graph this one. Our first one is in slope-intercept form, so that's good. So let's go ahead and graph it. I need a few points. Well, I'll just grab one, take it over there, and then I can copy and paste it. All right, the first one's already in y equals. So we are going to go up to for our y-intercept. Copy and paste so we can have another point. Control C, Control V to get other points. So we want to do our slope. So on this, it is down to right 3. Down to right 3. Next one, down to right 3. Down to right 3. Y'all check me. Make sure I did it right. Now draw a line through it, through all of those points. Darken the line up and add arrow on the end. Okay, but the other one, that is not in y equals form. So in your journal, we are going to solve this. So this is now slide 13. Slide 13, systems of equations. So this is 2x plus 3y equals 6. So we need to solve it for y. It needs to be in y equals mx plus b. So minus 2x. And we get 3y equals negative 2x plus 6. I always do the mx plus b. So I always reverse these, but I take the sign that's in front of it with it. So negative 2x plus 6. Then divide by 3 all the way through. So y equals, it's still negative 2 over 3x plus, what's 6 over 3? 2. I feel like I've seen this equation before.
It's the same.
It's the same. So they are the same equation. So I'm going to copy and paste the line, but color this line a different color. Color it yellow. And it's on top of the other one. So what is our answer then? Yeah. Infinitely many solutions. And we need the symbol for infinity. So insert special character and then draw the infinity sign. I'm going to make this bigger. Oh, whoa, too big. Maybe make this one bigger. There we go. Okay, our last example for today. Right over here. Okay, we have two equations and they're both not solved for y. So we got a little work to do before we can graph them. So let's write these two equations in our journal. Which I need to write them separate. I don't know why I wrote them right on top of the other. That just means I need to write them again. Okay, so I need to get y by itself. What's step one? Yep, minus 2x. So we have 5y equals negative 2x plus 8. Divide by 5. So y equals negative 2 over 5 x plus 8 over 5. 8 over 5 and 2 over 5. Well, this one's, you always want to write slope in the fraction form. But then we would reduce this if we could. What is 8 over 5? That 1.6? Okay. All right, let's just leave it like that. Let's do the other one. Negative over negative becomes positive. And then 5 over negative 2. Let's just leave it like that. So these are our two equations. Those don't seem very fun to graph. So what we can do is we can create a table of values. We just need 2 points in order to graph, right? Okay. So let's go to y equals and put in one equation at a time. So we can find just 2 points. That's all we need. Then we can graph it. So negative 2/5 x plus 8 over 5. We're not finding the intersection point yet. We're just finding 2 points so we can actually graph it. Now go to your table of values. We need 2 whole number points, right? So looks like 40 is a good one. And then negative 1, 2 is another one. You can pick any whole number points, but those were just 2 that were the first that I found. Okay, so let's graph that one first. So a point at 4, 0, over 4 up 0. So it's on the x-axis. And then what was the other one? -1, +2. We need a line. Okay, and then the next one is 3/2x minus 5/2. So we need to go back to the y equals, clear what's in there, put this one in there. 3/2x minus 5/2. We need 2 points. Go to your table. I have -1, -4, 1, -1, and there's actually 5, 5. So I have a few points I can use. So let's plot those points. So -1, -4. One, 1. Oops, that doesn't touch quite, does it?
No.
Nope, it's not exactly on there. Okay, and then 5, 5. One, -1. Whoops. There we go. I was wondering why it did not look like it was lining up. Okay, now we'll draw the line. Okay, I'm going to zoom in. There's my point of intersection. So let's do a little scribble over it. What is that close to? It's close to 2, 1, but is it exact? It's not. So what we have to do is we have to put it in the calculator and find our exact solution. So go to y equals. We already have the second one in there. So let's put the first one in there, but in the second spot. So I would put in the -2/5 x plus 8/5. It doesn't matter what you name y1, what you name y2, as long as they're both in there. So now graph it. It should look the same as ours. So let's do the calculate steps. So once you have it in, second trace, which is calculate, intersect number 5, enter, enter, enter. And there's our solution. Let's round it to the hundredths, which is your 2 decimal places. So that'd be 2.16 and 0.74. .16 and 0.74. Okay, so we are finished with notes. No homework today. You'll have an assignment to do tomorrow in class.